All right, so we are getting ready to start Unit 6, which has to do with conic sections. And kind of unlike the other ones, I'm going to do a precursor to this because I think it's good that you understand what conic sections are. So instead of jumping right into 6.1, 2, and 3, we're going to start with kind of a precursor. So a conic section is basically what would be considered a double cone. And you can see the illustration down here that I've given you. It's a double cone in the fact that you have a cone which normally looks like your standard ice cream cone or something like that, which is the part facing up, and then you have the part which faces down. And the double cone meets at the vertex V. So this little point right there in the center, that's the vertex where the cone meets. And that literally is one point. The upper part of the cone is called, or the upper and the lower parts of the cone are both called nappes, N-A-P-P-E-S. The upper one is obviously called the upper nap, and then the lower one is called the lower nap. The way a cone is actually formed, if you take a vertical line, which you can see, and they call that axis A, if you take a vertical line and then you take any other line and intersect it with that vertical line, as long as they are not perpendicular lines, and then you revolve it around an axis. A little bit too much to show graphically. There are some good YouTube videos out there which show the actual revolution of that thing. But basically, you've got a cone that faces up and another cone that faces down. The important thing about this, for what we're going to be doing, is realizing that what we can do is we can form what are called conic sections. Again, the word conic stems from the word cone. So these are sections which are created by doing something to this cone, this double cone that we see here. And what we're going to do is we're going to take a geometric plane and we are going to slice through this conic section in various ways to form what are called conic sections. Now, one thing it doesn't really show in your book is that if you were to take a plane and you were to slice it straight through the vertex, so it's really hard to draw this, and I'm not really going to do my best to try, but that was really horrible too. If you go right through the vertex, and just say I put a plane right through there, well, the intersection is just that one single point, so it's still a geometric figure of a point. Let's say that I take a plane, and I line it up right on the axis of this cone. So basically it slices, man, I'm just not doing very good with lines here today. So it slices right down the axis of that thing right there. Well, the intersection of the plane and that axis of the outside of the cone would simply be a line. Okay, so those are two very easy geometric figures that we can get out of this. So if you slice it right through the center, it's just a point. The intersection, if you slice it right along the axis, if you think about setting a plane right along the axis of the outside of this thing, I keep saying the axis, I apologize, around the outside of the cone, it just forms a line. Not the ones that we are really interested in. We are far more interested in what we're going to have on the next couple of pages. So you can slice a cone in a few different ways. I can slice it so that the slice is perpendicular to the base. Excuse me, I keep saying this stuff wrong. It's parallel to the base. And these things are the bases. This piece is a base. This piece up here is a base. So if you slice it parallel to the base, you're going to get something. If you slice it just a little bit off of that axis, but it still goes through only one part of the cone, only one nap, then you'll have something else. If you slice it so that it goes through one part of the nap, but it actually goes through the base, that'll give you something else. And then if you slice one that goes through both naps and through both bases, that's the fourth one. So let's take a look at what these look like. The first one is the easiest one. If you slice it parallel to the axis, parallel to the base, what you can see, this one right here, is parallel to the base. It just forms a cross section of a circle. So that thing right there is a circle. I'm going to erase that green line because I am not doing it justice with my drawings right now. So that would be something which is sliced parallel to the base. Okay, we're actually not going to discuss circles. That's one of the 4 basic conic sections that we're not going to discuss because we've already talked about circles enough that we don't need it here. But what we are going to discuss are the other 3. So now you can see what I've done is I've taken the plane and I've tilted it just a little bit, so much that it still goes through both of these sides here of the nap, and it doesn't go through the other part of the cone. It doesn't go through the bottom part of the cone at all. Well, what that does is, because I've tilted the axis, it's now no longer a circle. It is what is called an ellipse. So if you were to look at just a 2-dimensional sketch of this thing from the side, it would look something like that. A lot of people think of it as like an oval. It's really a stretched out circle. Or, to be more precise, a circle is an ellipse that has no stretching to it. So really, circles are ellipses, but ellipses are not circles. It's one of those whole rectangle, square, square, rectangle deals, if you know what I'm talking about there. So this has what is called eccentricity, which is how much it is stretched in one direction or another. Whereas a circle has a constant eccentricity. It's all the same all the way around. So that's an ellipse, which will actually be the, I think that's going to be the second one that we go over. The third section, it's the one we're probably more familiar with than any, is if you were to go through one nap and its base. So it actually won't touch the other nap at all. So it basically has to be parallel to the generator line, which is this one right here. It's got to be parallel to this. But it's going to cut through one nap, and then it's going to be go through the same base as the nap it is. That's going to form the parabola. And again, you all have seen this several times. But that's how your parabola is formed. And we'll actually talk about how this piece right here is related to the parabola, because it has a very specific name when we get into it. The parabola will be the first one that we actually go into. And then the last piece that we're going to talk about is what's called a hyperbola. And that has to basically go through both naps and both bases. And they kind of look like, although it's not the same thing, they kind of look like a parabola that opens one way, but then there's a parabola which opens the other way. So they kind of look like parabolas, but they're not really parabolas. They don't follow the exact same criteria. But they kind of look like parabolas opening in opposite directions. All right, so there are the 4 conic sections and how they are formed. If you don't actually ever remember how they're formed, it's not a big deal, but I think it's important to introduce the concept so that you know where all this stuff comes from, instead of just knowing that, oh, I have some equation and this is a parabola. What's actually developed by slicing a cone with a plane in various different ways. All right, so when we come back, we'll be doing section 6.1, and that will be parabolas.